Hi, welcome back to our Honors Geometry series. Today we're going to go through our 2.7, 2.8 notes. This is just kind of blending the end of 2.7 with 2.8, all about proofs, segment addition, and angle addition postulate proofs. We're going to give you sort of the general heuristics of proving things. And in general, we'll start our proofs with the given statements. So you start with the givens. After the given statements, you want to do any definitions. You want to define any vocabulary words that might be in your given statements or in the pictures. Thirdly, you want to do segment or angle addition postulates. As far as these two sections are concerned. And lastly, you want to substitute anything that you can. Substitute anything possible that you can to get closer to what you really want to prove. In this case, I want to prove that AM is equal to 1/2 AB. I want to start with M is the midpoint of AB. That's given. So M is the midpoint of AB. And then I'm going to look for my definitions. Are there any vocabulary words in the given statement? Well, yeah, midpoint. But what does it mean to be a midpoint? To be a midpoint, if M is the midpoint, well, that means that AM and MB must be equal. So AM must equal MB by the definition of midpoint. So if AM equals MB, M is the midpoint. If M is the midpoint, AM equals MB. Okay. And then I do my segment addition postulate. But what does segment addition postulate look like? Well, it looks like AM plus MB equals AB. Part plus part equals the whole segment. And I'm going to stop right there. Segment addition postulate. I'd like you to pause the video and see if there's anything you can substitute to get just AM and AB in your equation. So look at step 3. I want AM equals 1/2 AB. So I only need AM and AB. What do I need to get rid of in step 3? And how could I substitute something else in to get rid of that term? I'd like you to pause the video and try it on your own, and then when you're ready, unpause and check your work. So step 4, I want AM and AB, so what I need to get rid of is MB. And let's see if there's anything I could substitute for MB. Well, let's look back at the first 2 steps of our proof. What else could I say is equal to MB that I could substitute for MB? Well, instead of MB, I could put AM because they're equal. So AM, and I'm going to put another AM instead of MB, equals AB. That's substitution. And at this point, I would encourage you to pause the video and really finish this proof on your own. I believe you could finish it by yourself. All right, so here I would get 2AM equals AB. And you could say combine like terms or simplify. Either way is fine with me. And finally, AM equals 1/2 AB. Now you could say multiplication property of equality. You could say that you multiplied by 1/2. That's probably more technically correct. You could also say that you divided by 2. So that would also work. I would go with multiplying by 1/2 personally because it is 1/2 outside of AB and not AB over 2, though those are equivalent statements. And if for some reason you ended up with AB equals 2AM and 1/2 AB equals AM, you could always use your symmetric property to switch the order to get it to where it looks exactly like your proved statement, what you're looking to prove. Okay, so we know the reflexive property and the symmetric and the transitive property for equality, but what does it look like for congruence? It's basically the same thing. Except you use segments instead of numbers and letters. So the symmetric property says that if AB is congruent to BC, then BC is congruent to AB. And the transitive property says that if AB is congruent to BC and BC is congruent to CD, then AB is congruent to CD. And you can try these if you'd like to identify the properties that are being shown. One quick note, my formatting got a little bit messed up here. Those should be congruence signs, but my PDF did not save correctly. So there you go. And you should have reflexive, transitive. This right here is the segment addition postulate. And then finally, this is transitive again. Okay, protractor postulate just says it goes from 0 to 180 on a protractor. And then here says that angle ABD, measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. We're going to skip example 1 for right now. We're going to go to another proof. So again, what are those heuristics that we like to use? Copy these down. Okay. Okay, we like to start with our givens. So measure of angle 1 equals 23 degrees. Measure of angle ABC equals 131 degrees. Look in your picture. Is there any other information that we know that's given in the picture? Well, we also know that measure of angle 2 equals 90, because that right angle there, that's given. I'd like you to try this proof on your own if you can. Again, look at your heuristics, your 4 steps, your algorithm to proving. There are no definitions that we can use, so we're going to have to skip straight to the segment and angle addition postulate. Angle addition says that measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals the whole thing, measure of angle ABC. That's our segment. That's not the segment, that's the angle addition postulate. Got to watch out for those. Easy to get into a groove. Angle addition postulate. Okay, step 3. We're going to substitute some known values. We did our givens, we did our definitions, we did the segment postulate or angle addition postulate. Now we're going to do substitution. What can I substitute in for those known values? And again, this is another good one where I think you can get the whole proof on your own just from here. I'd like you to pause the video, try it, and then unpause and check your work. Okay, so you could do, in this case, instead of measure of angle 1, 23 degrees plus 90 degrees plus the measure of angle 3 equals 131 degrees by substitution. Now 4, I would like you to show the step of 113 plus the measure of angle 3 equals 131 degrees by combining like terms or simplify. You could also put simplify there. And then of course we have the measure of angle 3 equals 18 degrees. That's a very ugly 18. 18 degrees by subtraction property of equality. Now your book, typically books don't show that step. They go straight from 23 plus 90 plus measure of angle 3 equals 131 straight to the measure of angle 3 equals 18. I like to show that step in the middle. I think that's nice to really show the reader how you got 113, how you subtracted to get 18 from 131 and 113. I don't really like showing 2 steps in 1 step, especially in a high school course. I like to show 1 step at a time. But that's a really good proof. I'm going to skip down here. The supplement theorem says that if 2 angles form a linear pair, then they are supplementary. The complement theorem says that if the non-common sides of 2 adjacent angles form a right angle, so if these angles, the non-common sides, form a right angle, then these angles are complementary. Okay. You can pause the video and find the measure of each numbered angle and name the theorems that you used. You know, your reasoning, the right side of the proof column. You can do that on your own and then check with the completed notes online, but this is not really a thing that I think is worth putting in a video and just extending the length. Okay, this is our last proof for the day. We're given that ray DB bisects, there's a good word, bisects angle ADC. That's given. Then we're given nothing else. We want to prove that angle 2 and angle 3 are congruent. Okay, so this bisects ADC. Okay, well, there are some vocabulary words we can define here. Where's my, there we go. We got our givens down. Check that off the list. We can do some definitions now though. Why don't you try this proof on your own and then unpause as you need to get some help and check your work. So if DB bisects ABC, then what do I know about the angles? Well, if DB is a bisector, it cuts it in half. It means that angle 1 is congruent to angle 2. Now I want you to look back at your image, and I would encourage you again to pause the video and try things every step as we go along on your own before you get help, just to get that practice of being independent and thinking a little bit harder on your feet. So step 3, there's no segment addition postulate, there's no angle addition postulate. Look in your picture again to see if there are any other angle pairs that you notice. Let me erase this. Do you see any other angle pairs in there? I see angle 1 and angle 3 are vertical. So if these are vertical, if they're vertical, what do I know about those angles? If they're vertical, they must be congruent. Okay, let's check back. Did our definitions, there's no segment angle addition postulate. I'm at the substitution step, but I don't know what to substitute. So let me look back at my prove line. What do I really want? I want to show that 2 and 3 are congruent. Can I do that? can I show that 2 and 3 are congruent just from this? Well, I can, because if 1 is equal to 2 and 1 is also equal to 3, then angle 2 must be congruent to angle 3 by our old friend, the transitive property. So a bit of a shorter proof, but I got where I wanted to go. That's our angle addition 2.8 unit with a little bit of 2.7 thrown in there just for good practice. Please try your best on the homework. Send me emails with whatever questions you've got. Let me know what I can do to help you out. Otherwise, we've got our test coming up soon, so you definitely want to get help